In this lesson, we'll go through an example where I show you how to calculate the velocity change using the conservation of momentum. The question reads, James Bond is skiing along being pursued by Goldfinger, who's also on skis. Assume no friction, Mr. Bond at 100 kilograms fires backwards a 40-gram bullet at 800 meters per second. Goldfinger at 120 kilograms fires forward at Bond with a similar weapon. What is the relative velocity change after the exchange of 6 shots each? No bullet hit Bond or Goldfinger, thank goodness. So here we have James Bond that's on skis. Let me try to illustrate this. So those are skis, and we have James Bond is on his skis, and he is shooting this way. Okay? Now he's looking backwards while he is moving in this direction. And then we have Goldfinger, who is shooting forward, obviously. Just from this illustration alone, if James Bond is moving in this direction and he's shooting a gun, firing in this direction, the gun will push him forward. Whereas the opposite is true for Goldfinger. If he is shooting his weapon and the bullet is traveling this way, the gun will push backwards and make him slower. So just from that, we can tell that the distance between these two people will increase after more shots are taken. Now, how can we use the conservation of momentum formula to help us with this problem? First of all, that formula is P for momentum is equal to the mass times velocity. So let's find out the momentum change whenever James Bond shoots. We can say that the mass times the velocity of the bullet is equal to mass times the change in velocity for James Bond. Another way to look at it is that this plus this should equal to 0. Let me show you. mv plus mv should equal to 0. Now if we set that going to the right is positive, since velocity is a vector, and going to the left is negative, then the value for this v should be negative v, and the value for this v should be positive. Now if I rearrange, where I bring the mass and velocity of the bullet to the opposite side, I should end up with that equation. If that didn't make sense to you, just set these two equal to each other moving forward. Let's start to fill in this equation. The mass of the bullet, we're told, is 40 grams. And make sure that the units for the mass are the same. So if James Bond is in kilograms and this is in grams, they have to be the same. So let's change 40 grams into kilograms by writing down what's 40 grams into kilograms. 0.040 kilograms. And the velocity of each bullet is 800 meters per second. For James Bond, his mass is 100 kilograms, and we want to find out the change in velocity. So I'll display that as the change of v. Multiplying these two out, you should end up with 32 kilograms times meters per every 1 second. And we still have 100 kilograms times delta v on the right side. Next, if we want to isolate for delta v, we divide both sides by 100 kilograms. That cancels out. And as a result, we're left with 32 divided by 100, which is 0.32 meters per second. This means that every time James Bond shoots a bullet, his velocity changes by 0.32 meters per second. We have to do the same thing for Goldfinger. Then once we find his delta v, we can combine them. So again, m times v is equal to m times delta v. The mass of his bullet is the same thing. It's 0.040. And I'll ignore the units because I know what the units should be at the very end. The velocity of those bullets are also the same, is equal to his mass of 120 delta v. Solving for delta v the exact same way as we did here, you should get 0.26 meters per second. Notice the difference in velocity between the two calculations is due to the mass difference between the two characters. Now comparing these two numbers, this one and that one, not only is James Bond increasing in speed every time he shoots behind, but he's also going faster by 0.06 meters per second. If we combine these two numbers, 0.26 plus 0.32, we get 0.58 meters per second if these two people were to shoot simultaneously in the opposite direction. That's one shot. If we want 6 shots, we multiply this number by 6. So 0.58 times 6 makes 3.5, around there, meters per second. That's the speed difference between these two. So if they both started off at the same speed, after 6 bullets, James Bond would be around 3.5 meters per second faster than the other character. Hope that made sense. If you have any questions, leave them in the comment section below. Thank you for watching.